Hey guys, welcome back to Quiz online class. So let's focus on the oxidation aspects, on the reactions of what of the alkenes. Now the word oxidation means what addition of what of oxygen. So now when alkene undergo oxidation, what will be the product? What are the conditions? So in this video, I want to take you step by step on how to understand how alkene undergo oxidation and the various type of reaction, the products, the reagents used. Do you understand? So make sure you take it. So make sure you stick to the end of the video and take everything step by step. If you have any question, only leave it at the comment section. I will respond to that. So now let's first understand what's called the alkenes. Alkenes are what a double bond. All alkenes are what a double bond. And alkenes are what a pi bond and a sigma bond. Do you understand? So this reaction is under what addition reaction, addition of oxygen. So when alkene undergo addition reaction, now the first reaction we look at is what in our previous video we look at what the hydrogenation, the halogenation, the hydrohalogenation, the hydration. Now these reactions involve only breaking of pi bond to get is what a single bond. Do you understand? Now when it comes to oxidation here, now when alkene undergo oxidation, you can break the pi bond only. You understand? I can break both the pi bond and the sigma bond. Do you understand? So in the sense that you can only break the pi bond in some reaction when it comes to oxidation, and you can break both. So in the sense that this is what will happen here is that you break only this one or you break two of them. Do you understand? So when you break this one here, when a reaction involves breaking of only the pi bonds, you're going to get what one product, one product. Now, but when it involve breaking of what the both the pi bond and the sigma bonds, now you're going to get two or more products, two or more products. You understand? So in the sense that we have two type of what oxidation of the alkenes. Here we say without oxidation. Here we can say oxidation without the breaking of sigma bond. Here we have oxidation without what the breaking of sigma bond. Oxidation without the breaking of what sigma bond. Then we have oxidation with the breaking of sigma bond. So these are the what two type of reaction in which what alkenes undergo. So when you break only the pi bond, you didn't touch what the single bond. One product will be formed. Now, when you break both the pi bond and the sigma bond, two or more products will be formed. So this one involve what oxidation without the breaking of sigma bond. This one involve oxidation with what breaking of what sigma bond. Just so now the possible products you are going to get here when you break only the sigma bond. Now the possible products are going to be diols, and what peroxide. So now you can either form a diol or what a peroxide. That depending on the reagents you are what making use of, which are going to go into it in what in few minutes. Can either be a diol or what a peroxide. Now when you break both the sigma bond and the pi bonds, now these are the possible products. You can either get what a carboxylic acid. Can either get what a carboxylic acid. Carboxylic acid. Now you can either get the carboxylic acid, which is what CO. Yes. Then you can either get what alkanone. Can get what alkanone. You can get what CO2 water. Do you understand? So these are the what possible what products. So when you break the alkanes, when you break what when undergo oxidation with the breaking of both the sigma bond and pi bond, these are the possible products. Can either be carbonic acid, what alkanone, alkana, CO2 and water. Now, but if you involve the breaking of the pipe bond only, you can either get what a diol or what a peroxide. Do you understand? So this is just a summary of all of the reaction. So now let's take it what step by step. So let's take some first. Oxidation without what the cleavage or what of sigma bond, right? So remember, the first I said here is that now it can either form two products, either what a diol or a peroxide. So let's look at what the first one a formation of what diol. Yes, formation of what of diol. There are two reagents you can use to get to achieve this product. There are two reagents. Now, there are two reagents you can use what to get this product. Now, you can either use what code KMnO4. You understand? Or you can use or you can use osmium tetroxide in what pyridine. Okay, please look up. Now, these two products, so these two reagents are the oxidizing reagents used to oxidize alkenes to get a diol. Like it can either be cold potassium permanganate or ozonium uh, tetraoxide. So cold KMnO4, which what potassium permanganate, or use what ozonium tetraoxide in what pyridine. These two reagents will what produce similar what results. So now let's look at what the reaction. If for example here we have CH2 double bond CH2 and you have is what cold KMnO4. And the temperature is low. We have that I say cold chemical. That is other low temperature. Now you're going to form a diol. Remember that oxidation without the cleavage of sigma bond. That is, this don't involve breaking of the pi bond only. I don't understand. So you can just say breaking of pi bond only. You understand? Breaking of what of the pi bond only. So the first one is what? Oxidation of what? Formation of diol. And there are two reagents you can make it of. Is that use code chemical for all ozonium tetraoxide in what in pyridine. So what will be the product of the reaction? So it will only break what the pi bond. So you have CH2 CH2. You understand? So what up here, remember, is what is an oxidizing agent, right? So you add more OH here, more OH here. So you have OH, OH. Do you understand? So the name of this product here is going to be ethane 1,2-diol. Ethane 1,2-diol. Now, if you should use this one, osmium tetraoxide, you are still going to get the same results. CH2 double bond CH2. You have OsO4 slash pyridine. You understand? Pyridine. Now, you are still going to have similar products. So you have CH2, CH2, OH. The same ethane 1,2-diol. So this reaction is a little bit easier than the one we have to look at later. So what will be the product of a reaction where alkene undergo oxidation with cold KMnO4? It is what diol. So if for example you have CH3, CH2, CH, CH2. I have okay. Now, what we have here, remember that it will produce similar results, right? So it will only affect this one. So OH should be added here, OH should be added here, then the pi bond what will disappear. So you have CH3, CH2, C. So here we have OH and here we have what? OH. So what's the product of the reaction? One, two, three, four. So it's going to be butane, butane, one, two, diol. This is that. So what about if I have something like this? KMnO4. What will be the product of the reaction? So two OH will form here. So you have OH, here we have OH. Can you see that? So you can see that this also produces a diol here. So what will be the name of this product here? Going to be cyclohexane 1,2-diol. So going to be cyclohexane 1,2-diol as a what? As the product. Do you understand? So that is what the first one B formation of diol. So this is just what how they are be from and what the various what products. The various products. So let's look at what number two. Formation of what a peroxide. Now the reagents. So let's look at what the B formation of a peroxide. Now the reagents you are going to make use of here is going to be per benzoic acid per benzoic acid. Per benzoic acid in what? In hydrogen peroxide. Do that. Per benzoic acid. Now, per benzoic acid, when you have per benzoic acid, it's just like benzoic acid. Now, you like what? Benzoic acid. You understand? But what happen here? You remove what? The hydrogen. Remove what? OH here. Do you understand? So that way we have C6H5CO3 CO3H. It's called penbenzoic what? Acid. Penbenzoic acid, which is this one here. You understand? How many oxygen? Three oxygen here. It is really derived from what? Benzoic acid. Look at benzoic acid here. So now, but when we talk about benzoic acid, that is this hydrogen is being removed by what? OH, which is the other one here. You understand? In the presence of a peroxide. So when alkene react with benzoic acid, where what? In what? In presence of peroxide, it's going to be what? A peroxide. So let me give you a typical example. So now instead of saying benzoic acid, you can just put 6 is H5CO3H. So that is what reagent. So if for example here we have CH2. If for example here we have CH2 double bond CH2, then here we have C6H5CO3H slash H2O2. Now when we have this product here. So when two of them react together here, what will be the product here? Now, the product is a peroxide. So this is a peroxide CH2, CH2. This is called a peroxide. It's called ethane peroxide. Ethane peroxide. That is the what is mean. Ethane peroxide. That is these two form oxygen here. You understand? Just like a ring what oxygen. Do you understand? So that is what the product. For example, here we have CH3, CH double bond CH2, and here we have C6H5CO3H slash H2O2. What will be the product of the reaction? So you have CH3, CH2. Look at it here. So you can see that it will break what the pi bond. What happened here? Here we have from oxygen here. Do you see that? So this is what is the product. So the name of this one is called propane 1,2 epoxide. Propane, propane 1,2 epoxide. Now the main reason why it's called 1,2 epoxide is that the carbon 1 carbon 2 is what's kind of ring oscillate. Do you understand? So that is the name of the product. If for example you have this one C6H5CO3H H2O2, what will be the product of the reaction? You understand? Well, it's going to be like this. So it's going to be cyclohexane epoxide. Cyclo cyclohexane epoxide. You understand? So you can see how easy it is. So this is it for oxidation without the cleavage of sigma bond. So it's very easy. Like when I say, can either form a diol or a peroxide, and we have looked at it very well here. So now one of the main stuff or the reactions when it comes to the oxidation of the alkene, I give a lot of student headache is the one with the cleavage of what sigma bond. So that would be the next one I want to look at. Cleavage of what of sigma bond. That is, you are breaking both the pi bond and what sigma bond. So it involves this one here. It involves breaking of what of the two of them. Do you understand? So now, like what I say, the possible products that you can get the possible products you are going to get from this oxidation can either be what a carboxylic acid, a carboxylic what acid, and can either get a carboxylic acid which is what CO, can either be this one here, a carboxylic acid. Now this is one of the first the what possible products you can get, a carboxylic acid. Can either get what alkaline, alkaline which is what, so alkaline can either be what alkaline. Like can either be what alkaline, which is what is okay. A carbonic functional with what hydrogen, or it can be alkano, right? Now this alkano can either be which is this one here, or it can be what CO2 and what water. So depending on the reagent you are using and the what type of the alkene involved. So now we have two reagents that you can use to what get this what product. So the first one you can use is called it's called ozonolysis. Ozonolysis is okay. That means ozone. It's called ozonolysis. In place of zinc, in place of what of zinc metal and what strong acid. Look at something here. Ozonolysis, you can either what use ozonolysis. That is, when alkene undergo now when you react to ozone, it's called what ozonolysis. And you don't only use ozone, you use what zinc and what is strong acid. You understand? So these are the condition here. Now, the product you are going to get from this oxidation is that what you get I alkaline or what alkano. It's okay. Is that what you get alkaline or what alkano? That's the product. So when you oxidize alkene with what ozone, right? When you oxidize alkene with ozone, you're going to get alkaline and what alkano. That is what possible products. Now we also have what we call B oxidation, oxidation with hot KMnO4. That is hot potassium permanganate. You understand? That is you eat it. Now remember when you oxidize what cold KMnO4, we have what a diol, right? Now when you oxidize with what cold with hot KMnO4, now you want to get the products are is that you get a now is that you get a carboxylic acid a carboxylic what acid. Two, is that what you get a ketone, or you get what CO2 and what and water. You understand? So these are the possible what ways products are going to get. You understand? So this one involve oxidation with the cleavage of sigma bond. That is breaking both the pi bond and what and the sigma bond. Do you understand? So if you should use what ozonolysis, now the two products are either what alkana or what alkano. Now when oxidize what with hot chemical, it can either be what a carbonic acid, a ketone, or CO2 and water. So how do we know this thing here? So now before we move into this thing proper, I want to teach you something that is very important. Without what I'm about to teach you now, there's no way we will understand this thing here. You get? So let me teach you this stuff before we move on. So let me just explain it here for you. Understand this thing very well. If you understand what I'm about to explain to you, then this ones will be much easier for us to understand. Now, understand that we are talking about alkenes, right? And the two carbon that carry double bond are very, very important. So now we have what we call unsubstituted alkene, we have what we call monosubstituted alkene, and we have what we call disubstituted alkene. So substituted alkene, that's what I said. You understand? So you have what we call unsubstituted alkenes. So now what do I mean? That is the carbon atom that carry the double bond only have one hydrogen. For example, here we have a carbon, right? So if this carbon atom that carry what this two, if this carbon that carry what a double bond have two hydrogen, it's called unsubstituted what alkene. So you can say unsubstituted. And it's called what unsubstituted. Do you understand? So now that is the hydrogen. So that is the carbon atom that is attached to what to the double bond or that carry double bond have what two hydrogen. There is no alkyl attached. It's called what unsubstituted what alkene or carbon. You understand? Now, if for example here we now have one here that carry what one hydrogen. Remember what difference between these two here? This one carry two hydrogen, right? This one carry what one alkyl group can either be a methyl, ethyl propyl, depending on type of the alkyl arrow. Now, when this carbon atom carry only one substituent, one alkyl group, it's known as what mono substituted, mono what substituted what alkenes. Do you understand? So the two are not the same. Do you understand? So now alkyl can either be on or what mono, because this thing I'm explaining to you play a vital role to determine the type of way what product is going to get. Now, if for example here we have this guy. Now, remember we are talking about with the cleavage of sigma bond, that is breaking of the sigma bond, right? So when you are going to break this one here, now you are still going to break this one here. Now, this one is what substituted. What substitute. This one that carry two alkyl group. Remember, when you carry only one alkyl, it's called mono, right? Now, when you carry two alkyl group, it's called disubstituted. Di what substituted. Do you understand? So understand this here. Now, when it's on, it will give different products. When it's mono, you're going to give different products. When it's what di, you're going to give what different products. Do you understand? So understand this here. So let's look at it. Please take some down to understand it. So let's take the first one. So let's take ozonolysis. Now let's look at what the ozonolysis. 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 You understand? When you look at the ozonolysis, Now we look at what ozonolysis is. Remember I told you that ozonolysis can only produce two products, alkana or what alkano, right? So now understand this here. Mono mono substituted monosubstituted and unsubstituted, we produce we produce we produce the what alkana. It's okay. Now monosubstituted and what unsubstituted we will produce alkana. If for example you have, look at something here, and you oxidize it to ozone. You oxidize it to ozone. Remember, here we are going to break these two things here, right? Now, when you break this thing here, you are going to get two different carbon atoms. So now, fair enough, you are going to get this one, ReCH. Can you see that? So instead that when you break this one here, you have carbon, R, which is the alkyl, break to this carbon atom, that break from this carbon atom and hydrogen here. So you got to produce what alkano, the carbonyl functional group here. Just you got to produce what a carbonyl functional group plus if we have hydrogen, carbon, and what hydrogen, going to be what it can be what functional. Do you understand? So monosubstituted and unsubstituted, we always produce what alkana as a product. Two of them are called alkana. Now this one is the simplest alkana, which is called methanol. Methanol is okay. So that is unsubstituted when it was dyed with what ozone. Now you're going to produce methanol. Do you understand? Now why mono will produce any ketone depending on what the alkyl. Do you understand? So this when you what you was that this when I was that when the alkenes is that what monosubstituted or what unsubstituted. Do you understand? Now what about disubstituted disubstituted alk sorry disubstituted we produce we produce we produce what ketone. Is okay or it produces ketone or alkano. You understand? So if for example you have arrow C arrow is okay. Now remember you're going to break here, right? You are oxidizing with what? With ozone. Please understand this here. Now, when you're oxidizing with what with ozone, now look at something here. You want to look at this carbon atom, right? This carbon atom is what? Mono, because it only have one alkyl group. This one is di, right? This one here is di. And dissociates will produce what? Ketone. So you have RO here, CRO. So you have RO, carbon, RO here. Then what carbonyl functional P. This is that. So when you break, these two carbon atoms will want to form what the functional group, the carbonyl functional group. So when you break, here we have R carbon R here plus here have what R carbon hydrogen, right? So here we now form the carbonyl functional group. Just and so here is called alkana. No alkano. Here is called alkana. This is that. So now you need to be careful when you are oxidizing it. And try to what checkmate the type of alkene involved. That is they talk about the carry what double bonds. Now the alkyl attached to them. Do you understand? So that's where you have to what figure out the product. So now let's take a good example here. Let's look at example for the first one. Let's take example for the first one. Here we have CH3 CH2C. So now let's take this example. Now let's look at this example here. Now whenever you see alkene react with ozone, understand this here, you can only get two products, either a ketone or an aldehyde. You get, and it will always what break from here. So now I'm going to write this stuff so that you will understand it better. So here we have a carbon, double bond, carbon here. This carbon having what two hydrogen. Now this one have what hydrogen, what CH3, CH2, right? So now you're going to break from this other point here. So you want to figure out the two carbon atom, if they are mono or di or on. This guy is what is on, right? So when it breaks, this is going to form what? It's going to form can you see that? So when it's a break, so when it's a break here, it's going to form what methanol, right? Because it's what is on substance. So it's going to be hydrogen. It's okay. Plus now this guy here we're going to form other another what kit, another aldehyde or alkene. So but here I want to have CH3 because you are going to start from here. Start from 1, 2, 3, 4. CH3, CH2, hydrogen. Can you see that? So this carbon here is not having what hydrogen, still have hydrogen there. You don't want oxygen. Do you understand? So the name of this guy is called me. No, that is what the name of this company here. Why not also here 1, 2, 3? Here we have no. So in the sense that now when one butane, because the name of this guy is called one butane. When one butane reacts undergo ozonolysis, when one butane undergo what ozonolysis, now we have two products formed. Here we have methanol or what propanol. Do you understand? Now, what about if you have two butene, where you have something like CH3, CH, double bond, CH, CH3. Now go what ozonolysis. It's okay. Now that is it's going to break from here. You understand? These two are the same. So this one, just like here we have CH3, C hydrogen, CH3 hydrogen, right? Now, this one want to break right into two. So this one will form an idea. This one will form an idea. Two of them are the same. So here we have CH3, C hydrogen, right? Then a double bond oxygen here. Now, this one is still going to form the same thing here. CH3, C hydrogen. You get so here we have two products, two of them. Here we have ethanol, here we have what? Ethanol. You understand? So if you want to write the two of them to be the same, can you say, can you just do it like this? Can you just do it like two? You get that is when you oxidize two butene with what ozone, right? It's going to produce what these two products here. Do you understand? You want to produce what two ethanol, two ethanol molecule, ethanol what molecule. That is it. Do you understand now? So if you have something like this, CH3, CH, double bond, you have CH2, 2, CH2, CH2. You have O3, you have zinc, you have. Okay, so let's look at this product here. Look at this guy. So when I be giving something like this, what is the name of the compound? The name of the compound 1, 2, 3. 3 methyl 2, 1, 2, 3, 4, 5, 2 pentene. Now is a what is a common question in the exam. When 3 methyl 2 pentene undergo osmolysis in the presence of zinc under what acidic condition, what are the products? Understand that you have to break this one here, right? So we have to figure out the type of the alkenes involved. Remember this place out. So I will rejoice for some you understand. Here we have CH3, C, right? This carbon here is having a methyl and hydrogen double bond. Here we have CH3, here we have CH2, CH2, right? So you find that this one, when to break, you have to get two products here. Here we have CH3, C, with hydrogen, right? So here we have CH3. Now this carbon atom that breaks from this carbon atom now form the what? The carbonyl. Plus. Now I can say from CH3, CH3, C, CH3. Can you see that? So here are CH3, CH2, C, CH3. Can you see that? So here we have this stuff here. Yes, man. So you can see that here is what? Here we have butanol because is what? Is alkano is what? Ketone functional which called alkano functional. Here we have ethanol. So here we have butanol, here we have what? Ethanol. Do you understand? So you must understand this process here. So this is what you get when the what osmolysis. Now, but one of the most confusing parts is what when was that what hot KMnO4? What are the products? Now remember when I was dicing with hot KMnO4, these are the possible products you get. So this is what I want to get. This what happened here. Die substituted is going to produce what a ketone or alkane. Right there. Die substituted to produce what alkane. Very, very important. Please take note of this. Now, mono substituted we produce what? Carboxylic acid. It's okay, carboxylic what? Acid. Mono, we always for produce what? Carboxylic acid. Then on substituted, we produce what? CO2 and what? H2O. Very important. So you need to understand this thing here. It's very, very important. So we have to take one example. If for example here we have CH3, CH double bond CH2, and here we react with hot KMnO4 in what acidic condition. Please take note. Now, therefore, you have to what figure out the type of alkene that is involved. This one is what on. This one is what mono. Right there. This one is what is on. This one is what mono. And I tell that mono will produce what a carboxylic acid, right? So this one is just like CH3, C hydrogen. So this side produces what CO2 and what H2O. Now this side is what we produce what a carboxylic acid. A carboxylic what acid. You get. So here we are going to have CH3, C. Now normally, understand this here. Normally, if it's what is osmolysis here, this one could have produced alkane, right? Now, but since it's what hot chemical for what happened here, this one have changed what OH. That is the difference. Do you understand? That is the difference here. So the difference between hot and cold here that in the place of alkane now, here we have carboxylic what acid. Now instead of placing hydrogen here, you place what OH. Do you understand? So it's called ethanoic acid. Ethanoic acid. It's okay. Ethanoic acid. So plus what? CO2 plus H2O. That is it. So you can see how easy it is. Now let's look at another one so you understand. Let's look at another one so you understand. If for example here we have CH3, CH, C. So here we have CH2, CH2, C, CH2, CH, CH2. Okay, please look up. Now, when you oxidize it with what? Zinc. So when you oxidize what? Ozone, another word H plus U. What will happen here? Now, this stuff will be out here. This one, remember too that that's what we want to produce a ketone, right? So we have CH3, CH2, C, right? This is what this side. Do you understand? This one, this side here. Now, this one here is what? Uh, this side is what? Mono. Mono will only produce a carbonic acid. So here we have CH3, C. It's okay. So here we have butanol. Here we have butanol. Here we have ethanoic acid. Do you understand now? So this is just what a background of understanding the oxidation of what? Of alkenes, oxidation of what? Of the alkenes. So we have done a lot of things, you get. So what we want to do here is to go back to the videos and start understanding everything step by step. Yet if this video is helpful, please give it a like and subscribe if you have not subscribed, and leave a comment at the comment section. I want to hear from you if this video is helpful.